Look at this apple on your desk. Ordinary, right? But hidden inside it is the entire history of the universe. Let's pull back. The apple, the desk, your eye, you, the earth, the stars, all are connected. Now let's zoom in. Inside the apple are atoms, mostly carbon, oxygen, and hydrogen. Breaking them further, and you find protons, neutrons, and electrons, and even deeper, quarks and gluons. But none of these particles simply appeared here. These smallest units of form come from events of the greatest scale. When the universe first began in the Big Bang, it created mostly hydrogen and helium, the lightest elements. But what about the heavier ones, like carbon for our life, calcium for our bones, or iron in our blood? These elements could not come from the Big Bang. They had to be made inside stars. In the core of a star, nuclear fusion occurs under extreme temperatures and immense pressure. At the beginning of a star's lifespan, hydrogen nuclei collide and fuse to form helium. The process releases energy that pushes outward from the core and balances gravity, making the star shine. As the star ages, helium fuses into carbon, carbon into oxygen, and step by step, heavier elements are built, all the way up to iron. But iron marks a turning point. Fusing iron does not release energy. Instead, it consumes it. Once the core fills with iron, fusion can no longer support the star. Gravity takes over and the core collapses inward. At this point, the Pauli exclusion principle states that electrons cannot be squeezed into the same states. This creates an intense resistance known as degeneracy pressure. Only in massive stars that are at least 8 times bigger than our Sun, gravity overcomes this pressure, triggering a supernova explosion. In a fraction of a second, temperature rises to billions of degrees, and the stars becomes flooded with free neutrons. In this extreme environment, the rapid neutron capture process takes place. Atomic nuclei absorbs neutrons faster than they can decay, growing heavier and heavier, creating the heaviest elements like gold and uranium. These newly formed atoms are blasted into space, making into vast clouds of gas and dust. Over time, those clouds collapse again, forming new stars, new planets, apples, and us. Therefore, we are stardust, every one of us, and we all share the same cosmic origin, then surely here on Earth, there is no reason for division. We are the children of the stars, part of the same family.